Good. Morning, everybody. I know it's early, and unfortunately I do have some disappointing news, which is that this talk does not include Slack bots, Alexa, connected homes, smart cities, pizza ordering, or anything terribly exciting, nor does it include T-Rexes having a laser battle in space. Instead, we're going to talk about something that's a lot more like a healthy breakfast. Something that you should be doing, and in fact doing all the time, but in fact people don't tend to do. The bacon sandwich is too alluring. Database backups are something that is absolutely essential to everything you do, whether you're working in a serverless way or not. And so we're going to talk a little bit about the healthy breakfast and how we can bring together exciting rock and roll ideas in the serverless world to the boring and mundane things that make sure we all get paid. So let's first start by talking about some of the primitives of computation that we'll consider when we look at a serverless stack. So Lambda is interesting and extremely important, obviously, but there are other things that we need to build on in terms of these applications. Sorry about the flickering there. Yeah, tantalizing. You want to take a photo? Ooh, it's gone. Go fast, yeah. So, Lambda's great for logic. It's a way of creating business logic and ensuring that AWS takes away the undifferentiated muck of running that and making sure it's available. But you also have to consider things like, where does state live? For any of you who have used serverless technologies and put state inside of your functions, don't. It's a bad idea. It's great to use your serverless environment as a cache, but never rely on it to be there forever. And so state then has to go somewhere else, onto a system that gives you the durability and availability requirements that you might have for your application. So in most serverless applications, you're going to be using tools like S3 for object storage. That's where you want to store files. Or a tool like DynamoDB for database and ultra-high concurrency and low latency state management. And then to really wire these systems together, we also have to consider message passing. You're going to be invoking other pieces of logic, and yes, you may do that just within your serverless function. You might be calling other serverless functions. But a really important property of a lot of these types of systems is external observability. What are they doing while they're running? And can we observe their behavior? Can we inject new behavior into the system by observing what they're doing and intercepting that? So message passing through tools like API Gateway, Amazon Kinesis, SNS, etc. is really important to use to wire together your logic. We're going to talk about those details at the moment. I can just turn it around and hold the laptop up, maybe. It's too bad. So, for those of you who thought that this was just a big seating room at Pret-a-Manger downstairs, we are going to talk about things like Lambda. And for those of you who are here for the first day, AWS Lambda is, of course, a serverless compute environment. The idea here is that what you really need to accomplish is creating business processes. And serverless is really all about saying, my business is really most powerful when I can just focus on getting the job done and let the means by which that happens be somebody else's problem when I've considered that they're going to give me a system that is highly available, durable over time. And so Lambda is a great technology to focus your business logic on. But we also need components like Amazon Kinesis. So for those of you who haven't encountered it before, Kinesis is a real-time and, again, serverless streaming platform for data. The idea with Kinesis is that you should be able to originate a piece of information and then have as many consumers read that data and process it in whatever way they might see fit. So Kinesis allows you to start relatively small, 1,000 events a second, or 1 megabyte per second, and then scale up horizontally to customers are running at terabytes an hour. And with Kinesis, we really take away a lot of the problem and the muck of distributed systems architecture. The nice thing about working with Kinesis is when you're consuming data, you don't really know that you're working in a distributed way. You just have to focus on working with your little corner of the data. And if you then want to create a wider and shared context for your application, you can do that. You can code in lots of different languages. In fact, with Kinesis, consumers can be written in any type of language, and they can be built on a variety of different application environments like Lambda. And Lambda is one of the native connectors. And for those of you who haven't met her, we have one of the engineers from the Lambda team who maintains the Kinesis to Lambda connector. So a good person to ask any questions of if you're interested in talking about Lambda to Kinesis. One of the other important parts of Kinesis is Kinesis Firehose. Kinesis is actually a family of products, Streams being the streaming application, and then Firehose being the serverless streaming archive capability. With Firehose, you're able to originate events, but then rather than processing those in real time, Firehose takes responsibility for delivering those in a highly durable fashion to Amazon S3, Redshift, Elasticsearch, etc. And it'll do that every 60 seconds. So rather than being a streaming and near real-time processing environment, this is really where we want to be able to ensure that our streams are persisted forever. And when you're looking at your application architecture, there is one really important principle of streaming systems, and I would say generally your application architecture. When you receive a piece of information from a source, you should keep it. You should store information in its received and originating form so that you can do things like replay. Imagine what would be possible if you said to your stakeholders, we could actually replay our entire business from a week ago, everything, and use the unified log architecture, for example. So being able to store all of your stream data in its original form is extremely important, and Kinesis Firehose gives us the ability to do that. One of the destinations that you might want to put your events into is DynamoDB, and the one we're going to talk about in some detail. And again, some of you may not have encountered DynamoDB before, but it's a serverless database. Dynamo is one of my favorite services, actually, because it is really surprising and interesting to work with, and offers you some really powerful capabilities to build applications. So DynamoDB is a NoSQL database, yes. But it has the ability to work both like a document database as well as a column family database. You choose what kind of SDK you want to use to interact with the database. And every table that you create in DynamoDB isn't sitting on a cluster that you have to feed in water, but is totally independent of every other table. The tables have their own scaling characteristics. You can tell us exactly how many read and writes per second you want. And we do all of the hard work in the background to provide that table with extremely high availability and, crucially, very high durability. DynamoDB is always multiple availability zone. Regardless of how many read and write IOs that you want to do per second, you will always get data stored on multiple facilities. And that's at any scale. We have customers who've gone to many hundreds of thousands of write IOPS. And then crucially, they can scale that back down again when they no longer need that capacity. So it's a really different database, and you shouldn't think about it as, oh, I'm going to run my MongoDB cluster, I'm going to run a Cassandra cluster. There is no cluster. With Dynamo, Kinesis, Lambda, there is no spoon. Inside of Dynamo, we maintain partitions, no great surprise, and those are based upon what we call hash range partitioning. In the past, I think it had been a little bit hard to understand, well, how big and how far will my DynamoDB environment scale? And we want to be much more transparent about that. So you'll get a partition for every 1,000 write IOPS, 3,000 read IOPS, or 10 gigabytes of data. Full stop. And those are fixed ratios that you can't change. But as your database grows, then we will repartition that under the hood. If you want to add capacity, we will just horizontally scale that table across multiple partitions. And then a partition is hosted on multiple availability zones. This isn't something you can turn off, and it's one of the best features of DynamoDB, is that when you do a write to Dynamo, we always synchronously replicate that write to 2 separate availability zones. We label those as facilities here because there is a common misunderstanding that I don't understand how Dynamo works if I'm in a region that only has 2 availability zones. We always have at least 3 separate facilities that are operated as availability zones, even if one of those isn't exposed to customers, for services like DynamoDB. So across multiple facilities, we're always writing to 2 of those, and then the third write is asynchronous. And as you scale up, we're going to be writing to lots of different facilities as primary, secondary, and then the tertiary location. And we can do that across the partitions that you provision to meet your performance objective. The other cool thing that DynamoDB partitions give us are something called update streams. And this is a really different feature. So we want our database not just to be a sink of information, but also give us the ability to observe what's happening. I, as a consumer, might just be interested in the changes that are being made to a system. And absolutely, a good application architecture would have the application raising events saying what it did. But in some cases, for instance, for replication, you might need an actual stream of changes from the database. And we can implement change data capture patterns and whatever the case may be. But Dynamo gives that to us out of the box. You simply tick a box on your table, and you will be able to then consume data from a stream. That stream looks an awful lot like a Kinesis stream. So you ask, what about backups? I thought you were going to talk about backups. So Dynamo is a multi-AZ database. It is backing itself up, if you will, across multiple facilities at any time. Why would you need backups? And that's because people make mistakes. You know, human error can be a big factor, especially if you are running extremely fast and you are building on an application where, unfortunately, sometimes not every piece of business logic is available in an API. It is still a fact of modern business that sometimes you just have to go in and squirrel around in the database. I would highly encourage you not to do that. If that's part of your operational process is broken. And so let's be a little bit more generous and say, well, maybe it's down to application errors. Maybe somebody pushed a piece of logic to production that corrupts data. And I would encourage you to look at your applications, serverless or not, and say, not just do we have the ability to deal with this when DynamoDB is running, but crucially, how would you know it was happening? It's quite easy to say, well, we would know. But unless you have a canary that's built around things like data quality, it can be very difficult to know if a piece of code happened to be writing gibberish into your database. And unfortunately, in some cases, it's your end users that are going to find this first. That's bad. So even where we have a multi-availability zone database where it is going to be up, it is going to perform for you like DynamoDB, we still have the possibility of data issues, whether that's data loss through deletions or through corruptions. Now, one of the things that Dynamo allows you to do, its permissioning model is built through AWS's identity and access management system. You can simply say an application doesn't have delete rights. And I would strongly encourage you to consider doing that when you use DynamoDB, but appreciate that the impact on your developers could be high. What does it mean when an application cannot do deletes? And for those clever CS bods in the back of the room who are thinking, but I'll just implement optimistic concurrency control, I won't even let them do updates. My DynamoDB environment will be insert only. Okay, awesome. You may not need any of what we're talking about, but you do still have to think about what happens if the authoritative version of a new record is wrong. So, what do? Well, you should definitely take backups. We provide you the ability to take full backups of DynamoDB using data pipeline, and Amazon EMR. And I've crossed out serverless, and maybe I'm not allowed to talk about it here, so sorry. Don't run me out on a rail. But data pipeline is a serverless orchestration tool. It provides you the ability to run a workflow on a periodic schedule that consumes data from an input data node and writes data to an output data node. And one of the templates we've given you for data pipeline is the ability to take a full backup of a DynamoDB table. It does that using Hive, sitting on Amazon EMR, which is managed Hadoop, Spark, Presto. It's effectively a managed Yarn container. Now, I say it's not serverless because while we can treat Amazon EMR as a managed platform for big data tooling, there are machines that you can see in EC2. If you just filter those out of the console, then you could pretend that EMR is serverless. So let's pretend that that's what we're doing, yeah? We're just pretending that we can't see them. But in fact, you can. On EMR, you're getting a managed Yarn environment with Spark installed, all of the tools you want, and you absolutely can SSH into that box. You can become root, and you can configure that in any way you might want. EMR is as customizable as any Hadoop system you would run anywhere. And you can install whatever tools you might want to put on there. It's infinitely customizable through something called Bootstrap Actions. So we're taking full backups then, and if you don't have these running and you're using DynamoDB, please even turn them on during a break because it's absolutely worth doing. And there's two important concepts we need to consider when we think about backup and restore. And for those of you who haven't hopefully you've all seen this before, and this is old hat, but the RTO, or the recovery time objective, is if I had to restore some data, how long would it take for that to happen? So this is the contract you're making with your business users. If there was a problem, how soon could they expect to be back up? And there are a lot of different things that will govern your RTO. The amount of data you're restoring is one of them. But also how much horsepower you're throwing at the problem. And certainly in the DynamoDB case, if you do a restore through data pipeline and EMR using a single M3 large, that will take a lot longer than if you do your restore using 150 CC2s on the spot market for the same money. Or maybe not the same money, but close. So you have to think about not just how much data you're restoring, but also how much horsepower you're throwing at the problem to get that RTO to where your customers expect it to be. The other one is the RPO, or the recovery point objective. So if you had to do a restore, how much data would you lose? How much data are your customers willing to actually lose? And that is a very hard question to answer because it is very, very much dependent on the data. And modern RDBMS databases unfortunately have a very one-size-fits-all approach to answering the RPO question. You take a backup of the database. Well, DynamoDB is very different. Every table is independent, and therefore the RPO, the point at which that data was consistent, has to be considered separately. The RPO for a payment system, I would assert, has to be pretty close to zero. Yeah? The RPO for a system that's storing logs, maybe you could live with a couple hours. And so when we consider those two metrics in terms of a full backup, your RPO is really defined by how often you do full backups. And today, those backups consume I/O, and you need to consider the impact on your production application. Most customers might take nightly backups, which is pretty reasonable. But losing all of the payments that you actually process through a credit card provider since last night is not probably acceptable, right? So really important to consider. And then the RTO really is all about how many cores and how much data am I going to do when I do that restore off of S3. So we had several customers who are using DynamoDB at extreme scale and for extremely important applications, things that are handling money, things that are handling orders. We use it for our shopping cart. And so they said, well, how would I actually achieve an RPO of 0 when I consider data corruption as a possibility? How do I recover? I know the database is going to be there. I'm just concerned that it's right and that I have the ability to recover correct data. So we came up with this idea called Lambda streams to Firehose. And the idea was we should be able to take an update stream from DynamoDB and in near real time replicate that to Firehose. And then Firehose can push that on to S3, and we have a long-term, ultra-high durability archive that's 3 cents a gig. So it's very affordable to say we're actually going to back up all of our data. The bit.ly is there. Please go and see it and play with it. It's available on GitHub. It's been around for a while. And maybe you think, I am a Lambda ninja. I don't need that. I'll do it myself. Yes, it is sort of easy. Sort of. But it does support both Kinesis streams as well as DynamoDB update streams. So you can archive both the streaming application inputs as well as your database channel. It also gives you the ability to write transformers. So you could say, well, actually, my stream is in protocol buffers format, but if I create a file filled with protobuf, I'm in trouble. That's not very useful. So what I want to do is be able to decode that data and store it as JSON or CSV or whatever makes the most sense. Or you might say, I don't actually want all of the data because a lot of what's coming in my stream isn't useful, so I'm going to filter it out at that point. That tends to be a bad idea. It also does something called Kinesis Producer Library Deaggregation. So one of the really nice features of Kinesis, if you have really massive producers, is that we can run a piece of code called the Kinesis Producer Library. And it will aggregate lots of tiny messages into one much larger message that will allow you to run at that 1 megabyte per second per shard in Kinesis. And we have to be able to unwrap that. We use protocol buffers inside the stream to deliver those aggregated messages. And so we do all of that unwrapping. There is a separate module for that. If you need it, please let me know, and I'll point you in the right direction. It's on PyPy and on NPM. As KPL aggregation. It also does deterministic ordering of your records to the destination. When you receive messages from Kinesis, you will get those in a very specific order. And in most cases, you want to push those to the destination. But we have to batch them up. We have to consider you've transformed them, so that's all in there. And the last one, please tell me if you're interested, is user-defined routing rules. You might say, I'm consuming data off of a stream, and I don't want to put it in one location, I want to put it in 5. So we can do that too. So when we wire this all together, we end up with a really nice pattern that starts to allow us to think about an RPO of 0 for DynamoDB. You have an update stream on your table, and it's generating what we call old and new images. Old and new images means that we give you all of the data associated with a modification. If you're doing a delete, then you only get an old image. If you're doing an insert, you only get a new image. Otherwise, you get both. You get every single change that was made. And you could change that if you wanted to and just have the new images. But it's very useful to back up both. That gets delivered then to this Lambda streams to Firehose. It's a black box. You don't have to do anything other than deploy it into your account. It just works. We then forward data to Firehose, and then that delivers data to S3 every 60 seconds. And we're done, right? Not quite. Because we need to ensure that people follow the rules that allow us to have continuous and incremental backups. We need to make sure that people can't do the wrong thing. So the components of the solution are I have to have a Dynamo update stream, I have to have a Firehose delivery stream, I have to have Lambda streams to Firehose deployed in my account in the first place, I have to have the Dynamo stream wired to my event source in Lambda. These are all mandatory configurations that now you're really trusting your developers to make sure that when they do a release and they create DynamoDB tables that they've included all of this. And an important question to ask yourself is, do you rely on policies to govern your environments? Or do you just say, actually, that's always going to be prone to human error. Let's use technology to do this. So what I'm going to talk to you about today is really where we said, actually, we can't leave this to chance. Database backups are too important. There are going to be a class of tables which are so important we have to have an RPO of 0. And we can't allow the possibility of human error that we don't get that. So we're going to take advantage of another piece of technology, which again is serverless, called Amazon CloudTrail. CloudTrail gives you the ability to have logged all of the events that occur on your account. Absolutely everything that happens that any user will run will be archived to S3. The first trail is free. If you don't have CloudTrail running on your account, again, in the break, go turn it on. It's free, it's a no-brainer. This will allow you to see what's happening across your environment and to start to become reactive to where things are happening in your environment. It's really, really simple to set up. You just give it a name, and then it does a really cool thing. It's one of our global services. So CloudTrail can manage all of the events that happen anywhere in the world across all 14 regions coming into a single location that you specify. And it will then manage that delivery, it will do encryption, it will validate that the encrypted files are correct and that they aren't corrupted for any reason. If there was a corruption, we'll manage that for you. And then we can even notify you when we generate a file through SNS, the simple notification service. But for our purposes, it has another really nice feature, which is you can tick a box and your CloudTrail will be forwarded to something called CloudWatch Logs. CloudWatch is our monitoring system that's built into many of our services. And CloudWatch Logs gives you the ability to consume logs like streams. You can see where I'm going with this. CloudWatch Logs is one of the event sources that we can wire into Lambda. So it is absolutely possible to reactively and programmatically consume every change that's happening on your account and to do things. And that's really handy because we can do something which allows us to trap every time a DynamoDB table is created or destroyed via CloudTrail, forward those to CloudWatch Logs, and then use a module which is available to you at that bit.ly link today in Lambda called Ensure Dynamo Backup. It just takes those Dynamo events and it says, hey, if I see one of these tables being set up, I'm going to go in and make sure that it follows our RPO of 0 objective for configuration. And to do that, it's going to go and it's going to make sure you have an update stream provisioned. It's going to make sure that the Lambda streams to Firehose function is deployed. This is quite a nice pattern if you've not used it. It's a little bit funky. It's Lambda function deploying a Lambda function. But it works well. It only happens once, obviously. And then we also provision the Firehose on the back end. And if our developers have done the right thing, if they followed the implementation process and their CloudFormation template has all of these things built in, awesome. It's not like it's going to fail. Just make sure that those are all in place. And this is happening as a one-time thing. You install this in your account, and it just happens. You will always have this continuous backup and archive model built into DynamoDB. Because the update stream then automatically will be wired to Lambda streams to Firehose. And you now have a foolproof way of ensuring that every single change made to DynamoDB is available on Amazon S3.
Just to clarify your detail, are you saying every event in CloudTrail gets logged to CloudWatch as well, so you can access it? You don't have to wait for it actually in S3?
Good question. So the question was, will every event in CloudTrail be pushed to CloudWatch Logs? And do we have to wait for delivery to S3? In this case, this solution, if you use what's at the bit.ly link, it does filter and only routes DynamoDB events to CloudWatch Logs. And the delivery delay on CloudTrail can be up to 15 minutes. So we do a regional sweep every 15 minutes and deliver those to the endpoint in your trail. So this could take as long as 15 minutes to propagate a DynamoDB create table statement into CloudTrail and therefore be provisioned. Quiet times, it will be much lower but that's the SLA that we provide.
And in this case, if the trail is not global but only regional, is it 15 minutes as well, or is that total to time?
Yeah. It's up to 15 minutes regardless of.
Regardless of
Mhm.
Why wouldn't you just use CloudWatch events and get that event you care about on CloudTrail much earlier?
So it really comes down to the delay and how quickly we want to be able to archive those. So there is a delay associated with CloudTrail. CloudWatch events, so the question was, why would you use this architecture instead of just using CloudWatch events? So CloudWatch events is really about scheduled execution. CloudWatch events allow you to create a cron-like syntax every 5 minutes. So implicit in the definition of that, you're kind of talking about a 5-minute delay to being able to do something. And as well, what we're after is a continuous backup capability. And DynamoDB update streams and so on is delivery in less than 1 second of a change. And so that meets our objective a lot better than something like CloudTrail events. But keep in mind, this is a very lightweight process for the CloudTrail integration. This is only every time you create a table in DynamoDB, which doesn't tend to happen 1,000 times a second. If it does, see me after, because that's weird. But you're going to create tables infrequently. And then, of course, the opposite model is here. So if you drop a table in DynamoDB, we will deprovision the update stream that is used for this backup. You can actually have multiple update streams. We will deprovision the Kinesis Firehose stream, but we will not remove your backups, obviously. You may want to go back to those. So, one more question.
Those Lambda functions, do you plan on having blueprints as available blueprints when we create Lambda functions so we can think of this architecture?
Sure. Question was, do we plan to offer something like this as a blueprint inside of the Lambda console? There's no plan to at the moment, but happy to chat about how useful that would be. We can see about that, sure. So, we're good. We have full backups, and we have real-time incremental change capture being done to S3 via Firehose, and so we're done, yeah? Oh, no, because we haven't talked about restore yet. How do you do a restore? Well, we've got these lovely files being delivered into S3 from Kinesis Firehose, and they look a little bit like that. You'll have a key, you'll have a new image, and you'll have an old image. And what we'll do is we'll use EMR, so again, this is, maybe consider this an appendix because there are servers, so sorry about that. We'll use EMR and we'll install, in this case I'm going to show you how to do it with Hive, but it doesn't matter how you would do restore. We're going to spin up an EMR cluster, we're going to use Hue and Hive to query that data at rest and answer one of the most fundamental questions, and the one that I would put to you and ask you to think about, which is, how do you know your data is corrupted in the first place? How do you find it? And how do you deal with large-scale operational events? If you push a piece of application logic that's corrupting data, and it sits there for 6 hours, you've got a big problem. And the first thing you have to do is figure out what was changed and what was corrupted. And doing that analysis in a very structured way is extremely important for your service to plan. I don't think that it's enough to say, well, we'll just revert the entire database to last night and get out of jail free, because you might have unreconciled payments. That's not going to work. So what we can do is use Hue to add a JSON parser. We can then use something called create external table to create something like a SQL table on top of our backup data. You can see here that it's got keys, new image, old image, and then the sequence number. Every single change made to our Dynamo table will be in this backup set. And then you just tell it, hey, what's the location? One nice thing about Firehose, it builds in time into the structure on S3 so that you can find specific changes and really target a range of time. And then, great, we just issue a query. Go out, give me the old image, the new image from my table add a timestamp, where the keys maybe were the ones you were interested in. You can do this exploratory analysis, which is absolutely the first step in considering how you do a restore. And if you were to issue that query, you would see something like this. This is an example from an IoT platform we've been working on. And what you can see is that you have event counts, and you can see that those are ratcheting up over time, sequenced by the number. So every single change that's being made to that Dynamo table is available to you. And now comes the really hard part. How do you do a restore? The number of applications that will freak out if you change the database underneath them is significant. And the best restore architecture is one probably where you originate change events into the top of the application. And I would strongly consider this aspect of doing backup and restore for your applications. So serverless isn't just about Lambda. You also have to consider the streaming replication aspects with tools like Kinesis and archiving your data with Kinesis Firehose. We need to consider services like CloudTrail and CloudWatch monitoring and CloudWatch logs for serverless communication of data. S3 is absolutely important for serverless systems. It'll give you this very long-term durability of data and a low price point that allows you to store everything. And then things like orchestration of your applications over time through tools like data pipelines. So putting that all together, then you end up with this really nice module, and I would encourage you guys, turn this on. It's all open source and available to you. You install it into your account, and then you forget about it, and you just make sure that backups are happening. And then at least, if you have an outage event, you can come back and say, hey, how are we going to fix this? Thank you.